So welcome to Greenhouse. So today's topic we're going to look at how to calculate the relative molecular mass of a compound. We're going to look at how to calculate the relative molecular mass of a compound. So that's what we're going to look at today. Now, for you to be able to calculate the relative molecular mass of compounds, you must know the mass number. You must know the mass number of the individual elements. Let's take a look at, if you have something like sulfuric oxide, like sulfur 4 oxide, this is sulfur 4 oxide, you must know the mass number of sulfur. You must also know the mass number of oxygen. That is the first thing you must take note of. So what of magnesium oxide? If you are told, please, what is the relative molecular mass of magnesium oxide? This is a basic oxide. You must know the mass number of magnesium and also the mass number of oxygen. If you have H2SO4, which is hydrochloric acid, if you have hydrochloric acid, H2SO4, you must know the mass number of hydrogen. You must also know the mass number of sulfur and mass number of oxygen. If you have potassium heptaosochloride 6, if you have this compound, you must know the mass number of potassium, your mass number of chromium, and mass number of what? Of oxygen. So those are the basic things. As a student of chemistry, basically, you must try your best to be able to know the mass number of individual element in a compound. That is the basis at which you'll be able to calculate the mass number, the relative molecular mass of any compound. Now let's proceed. Let's say calculate the relative molecular mass of water. Calculate the relative molecular mass of the following compound. Calculate the relative molecular mass of the following compound. Now, how can we calculate it? Let's take an example, water. Let's take a look at water, H2O. This is water. Let's take B, H2SO4. This is tetraososulfate 6 acid. Let's proceed. Let's look at another compound. Let's say calcium oxide. Calcium oxide is basic oxide. And let's look at the last one, which is magnesium chloride. Magnesium chloride is a salt. Now, let's calculate. The first one, what is the first one is, now these are the elements, those are the compound. Like what I said earlier, you should be able to know the mass number of the element that make up the compound, the mass number of individual element that make up the compound. That is what we are going to do. So the first exercise we are going to take a look at is exercise A, which is water. H2O is water, right? Good. Let's proceed. Which is equal to the mass number of oxygen is 1. Now, before we proceed, let's write all the mass number of all the elements. Hydrogen 1, oxygen 32. As a chemistry student, you must put the value in your mind, because most questions, you will not be given this value in most questions. You should be able to bring it from your mind. Then, let's proceed. Sulfur is 32. Calcium is 40. Magnesium is 24. Magnesium is 24. Chlorine is 35.5. Chlorine is 35.5. Chlorine is 35.5. Let's proceed. So water. Now, what is the mass number of water? Of hydrogen is 1. Don't forget your subscript, which is 2. There is 2 here, okay? Times 2. Bracket open, bracket close, plus. What is the mass number? What is the mass number of oxygen? Is it not 16? It's 16. Which is equal to 2 plus 16 is equals to 18. 18 grams per mole. 18 grams per mole. This is the mass number. So now, the mass number of water is 18 grams per mole. This means, it means for every 1 mole of water, we have 18 grams per mole. For 1 mole of water, we have 18 grams for that 1 mole. So those values are very important. We will use it in stereochemistry to solve mass-volume relationship later. So let's take note of these values. Now let's proceed to number 2. B. H2SO4. 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 So we have, what is the mass number of hydrogen? The mass number of hydrogen is 1 times 2 plus, what is the mass number of sulfur? Is 32. 32 plus, what is the mass number of oxygen? Is 16, right? Good. 16 times 4. 16 times 4. 60 times 4. So we have 1 times 2, 2 plus 32 plus 60 times 4. We have 64 here. So at the end of the day, we are going to have 98 grams per mole. We have 98 grams per mole. So we have 98 grams per mole. This is for 1 mole of H2SO4, which is tetraoxosulfate 6 acid, we have 98 grams per mole. We still have other example to solve. We have calcium oxide. Let's proceed to calcium oxide. I want us to proceed to what? Calcium oxide. Calcium oxide. Calcium oxide. So let's go with calcium oxide. Calcium oxide. What? Calculate the relative molecular mass of what? Of calcium oxide. Now, what is the mass number of calcium? 40 plus Oxygen 16. Oxygen 16. So let's proceed. So we have 56 gram per mole. So 1 mole of calcium oxide is equal to 56 gram. That is what it means. Let's proceed to our last one. Magnesium what? Magnesium chloride. Let's proceed. What is the mass number of magnesium? It's 24 plus chlorine 35.5 times what? Times 2 is equal to 24 plus so we have 71 here is equal to 90 what? 95 gram what? Per mole. We have 95 gram per what? Per mole. So it means this is, of course, we know magnesium chloride is a salt. It means for 1 mole of magnesium chloride, it has 95 gram. For 1 mole of magnesium chloride, it has 95 gram. This is just like exchange rate, you know. For 1 mole of it's just like naira. $1, we know the equivalent to that to dollar, we know the equivalent to pounds. So this is how it is too. So most element, 1 mole of compound is not equivalent. 1 mole of any compound is not equivalent to number of gram for all the elements. It has a respective number of gram as a result of the number of component of element and their mass number. That determines the mass number of the elements. Determine the mass number of the element. We can proceed and look at more example. Let's look at calcium chloride. What is the mass number what is the mass number? What is the mass number of hydrogen? Is 1 plus 35.5 is equal to 35 So for 1 mole of hydrogen chloride, we have 35.5. We have 35 point what? 0.5. We can proceed. Let's look at this compound, oxidizing agent. Potassium heptaosodichromate 6. Potassium heptaosodichromate what? 6. Potassium heptaosodichromate 6. So now what we need to do now, let's calculate the mass number. Let's calculate the mass number of potassium heptaosodichromate 6. Now I want to respond to some questions. I can see some questions in the comment section. Some students are saying, sir, please, why are we calling this compound potassium heptaosodichromate 6? Why Why not dichromate 5 or 2 or 3 or 4? Right now, I want to demonstrate why it is. Anyway, of course, I know that is a different topic, but for the sake of that question, I want to explain why it is called potassium heptaosodichromate 6. Okay, let's proceed. But before that time, before that answer, I want to respond to this question by calculating the relative molecular mass of potassium heptaosodichromate 6. So let's go. The mass number of potassium, let's look at the mass number. Potassium is 39, chromium is 52, oxygen is what? 16, oxygen is 16. So with that, let's proceed. Let's proceed. So it will now be 39 times 2, bracket open bracket close. Then let's add plus what? Chromium. Chromium is what? 52. 52 times what? Times 2 plus 16 times what? Times 7. Let's proceed. 39 times 2, 78 plus 52 times 2, 100 and what? 4 plus 16 times 7, 112. $78 plus 104 plus 112. So by the time we add the value together, without the value, we'll be able to have the relative molecular mass of this compound, which is going to give us 198. Add the value together, it's going to give us what? 198. That is how we solve it. So we can proceed to another topic.